All right, example 2 tells us that quadrilateral STUV is a rhombus. Find measure of angle TUV. So first of all, it's a rhombus. What do I know about these two marked angles in the picture? They're congruent because the diagonals bisect angles, right? So this diagonal bisects angle STU, which means these two angles must be congruent, which leads us to an equation that 65 minus y must equal 5y plus 5. Obviously, that's not going to tell me what TUV equals, but it's going to give me more information that will lead me to that information I'm looking for. Right? 65 minus y equals 5y plus 5. I'm going to get y on one side, numbers on the other. I'm going to go ahead and take the negative y and move it to the right, and the positive 5 and move it left. Okay, and just a quick hint here. Most people don't like negatives as much as they like positives. Are you guys that type of people? You prefer positives to negatives? Most people, so. All right. So when you're trying to solve an equation, you want to make sure that you get more stuff positive than negative. Here's how you do it. It's real simple. If you look at the variable terms, and you want to decide which side should I move things to, right? Look at the coefficients and look at them based on their signs. Positive 5, negative 1. What's the bigger number between positive 5 and negative 1?
Positive 5.
Positive 5. In fact, the positive is always bigger, right? If you always take the smaller one and move it, you're going to get more positives. If you take the bigger one and move it, you're going to get more negatives. So if you want to avoid negatives as much as possible, that's a quick way of doing it. So if you got to decide which side do I want to move things to, look at the sides. If this was negative 5 and positive 1, positive 1 is bigger, move the negative 5. All right, so again, look at the sides of the numbers based on their signs included. Bigger, smaller, move the smaller variable term. That makes the most positives. So 5y plus 1y makes 6y, and 65 minus 5 makes 60. These were the same, so I added different, I subtracted bigger number positive in all cases. Divide both sides by 6, gives me y equals 10. Okay. Now, my task, of course, is not to find what y equals. My task is to find out how big this angle right here is, TUV. All right, what I know about a rhombus is also a parallelogram. These sides are parallel, these sides are parallel. These parallel sides cut by this transversal mean that this angle up here and this angle down here are supplementary to one another, right? So in a rhombus, we have consecutive angles being supplementary. So if these two angles add up to 180, if I can figure out how big this angle up here is, I can then figure out how big that angle down there is. So once I know y equals 10, 65 minus 10 makes 55. 50 plus 5 also makes 55. That not only gets us more information, but it also verifies we did everything correctly, right? These are supposed to be equal, and they are equal. If I add those up, I get the measure of angle STU is 110 degrees. And I know that 110 plus, let's call this x, 110 plus x should equal 180. Because again, consecutive angles in a rhombus must be supplementary. So if I solve this, move the 110 over here, I get x equals 70. And x is what we're looking for. So measure of angle TUV equals 70 degrees. So use the properties of a rhombus in order to find some information that leads you to what you're looking for. Sometimes you kind of walk down a little bit of a path to get where you're going. They can't immediately find what you're looking for, but you can use what they give you to find more information that eventually leads you to a property that gets you what you're looking for.